For BBE DSARI project, I would like to see how renewable energy works in real life. So I chose the energy tour to Morris campus on March 3rd. After arriving at the Welcome Center, I asked a few questions about the background information and things I had been interested in. So the WCROC is located on the edge of the prairie, where wind energy and cropland are abundant for researchers. For renewable energy programs, the very important thing is to make the most use of local resource and benefit local environment as well. So let's move on to the field and see the wind turbines. Wind turbine can provide more than 50% of the new Morris energy needs, and the value of electricity generated itself is more than that we purchase from the power companies. So we can make profits at the same time, which is pretty awesome. Apparently, there is a very strong wind out there, and seeing wind turbine in person makes it appear much larger than how we usually see it. To drive the wind turbine, wind speed should be up to between 8 and 50 miles per hour, and the average wind speed at Morris is 17.5 miles per hour and 70 meters. More remarkably, compared to electricity produced from coal, wind turbine can avoid 7,600 tons carbon dioxide, 27 tons of nitrogen oxide, and sulfur dioxide per year. And next, we went to see the steam turbine, which belongs to the solar thermal system. Basically, we use gas to heat water, and there comes steam. Then the steam goes into the steam turbine to produce electricity. The steam turbine can generate up to 300 kilowatts of electricity. The other thing we do here in summer is using this machine to turn hot water into cold water for air conditioning. Hot water that is boiled in the steam turbine flows into the chiller and then cools down, so we don't have to use electric chiller. While in winters, we also have this solar hot water system to replace natural gas hot water for shower, laundry, and other uses. Solar energy is collected through the plate collector and stored in a heat exchanger. When cold water comes in tank, it gets heated by the heat exchanger and then is sent to houses and buildings. We're trying to optimize this system, and it would be perfect if it becomes suitable for all kinds of houses and commercial buildings, I guess, because that would save a considerable amount of gas and electricity and avoids emissions too. So it is the flat plate solar thermal system that can provide domestic hot water. And we also have this evacuated tube solar thermal system that is even more efficient. Because they use a vacuum instead of traditional insulation, almost all heat loss is eliminated. Since there are few crops growing in winter, biomass energy system wouldn't be an important part of this tour. But from seeing other renewable energy system, I think I've learned a lot about how to efficiently generate energy and the efforts we made to convert energy type that we use. For now, we can be self-sufficient, but in the long run, how to use battery to store and transport energy still remains a big problem. When this system cover more and more areas, renewable energy can gradually replace other traditional energies and minimize the harm to the environment.